And without further ado, we have Ms. Chuka for Math 1314. The link for Math 1324 will be posted in chat. Can you and for that subject, please follow Mr. Isasi.
Thank you. Welcome everybody to another session of Friday Happy Math Hour. And so today we're going to be talking about zeros. So I'm going to go ahead and go to slide 51 because we've already covered the other ones in a previous session. And so the examples we're going to be looking at today, most of them will be from 2.5. And then examples for 2.6 will be covered next week when we review for exam 2. So at any time, if you have any questions, please let me know, and I will stop and answer those questions. Okay, so we've been talking about zeros for quite a bit, and so just as a quick review, the zeros are the x-intercepts that we can see here. Okay, and you have some here, and then you have some here. And then we also know that some are going to cross the x-axis and some are going to touch. And so we'll review that in a little bit when we start to graph some of the equations. But when you look at all the zeros, they all have something in common. And that item that they have in common is that the y is always going to be equal to 0. So notice the y is always equal to 0. Okay. And so one of the first theorems that we're looking at is going to help us determine how many zeros a polynomial should have. And basically, the number of zeros is going to be given by the degree of that polynomial. Okay, so you'll have the degree, which is um, the the n is the highest exponent, and that's going to tell you how many zeros you have. Some of those zeros are going to be complex numbers, and so we'll be able to discuss that as well throughout the session. So if we look at this example here, determine the number of zeros of the polynomial function. And so for the first one, you want to look at the highest exponent. So here we have a 3, and then here we have a 2, and then we have the 1. And so go ahead and in the chat, if you have I'm going to give you about 20 seconds to just tell me what you think the degree is for the first one. Okay. So yes, so your highest degree here is 3. So that's going to tell us that this polynomial is going to have 3 zeros. Okay. And then if we look at the second one, we have x to the fourth minus x to the sixth. And so the degree of that polynomial is going to be, is it 4 or is it 6? 6. So remember, it's always going to be the highest. Now, it tells us that there's 6 zeros. However, some of the zeros, as we've seen before, can be complex numbers. And so if it does have a complex zero, they come in pairs. Okay, so we'll talk about that whenever we get to some of those examples. So again, for the first one, we have 3 zeros. The second one's going to have 6 zeros. Last week, we did talk about finding zeros. And so these are just simple examples here. The main idea is that in order to find a zero, the f of x has to be equal to 0. And then we solve for x. So x here would be 2. So your zero is going to be 2. And then we have a little more polynomial with a higher degree, in this case of 2. So anything that is quadratic is a bit easier to solve because we can use so we can use quadratic function, the quadratic formula. We can factor or we can use the square root property. In this case, this polynomial is factorable, and so I can factor it as x minus 3, set each factor equal to 0, so we get x equals 3 as our zeros. So notice here that the 3 and the 3 is the same. So this still counts as two separate zeros. So we have 1 0 here and 1 0 here. We say it has a multiplicity of 2. And then the last one here, we can set each one equal to 0. And so 1 0 is 0, then we have x minus 2i is equal to 0. So we have x equals 2i and x equals negative 2i. So what can you tell me the degree of this polynomial? Just by looking at this, if these were all the zeros that we had, we can see that the degree of this polynomial would be 3. Okay. And so here you can see the graphs. Notice at the bottom graph, you only see that 1 0 because the 2i and the negative 2i are imaginary. And then the x equals 3, we can see that the graph is going to touch and turn because it has an even multiplicity. And then for the 2, the graph is going to cross because it has an odd multiplicity. Okay. Last week, we also talked about synthetic division, and this is just an example of that. Don't worry, we are going to do some problems using synthetic division today, but I just wanted to just touch up on some things here. So the last number here, this is your remainder. If it gets you a 0, then that tells you that x equals 4 is a 0. The other numbers to the left, this is going to create our quotient. And what we want is our quotient to be quadratic, because once it's quadratic, then we can factor or use the quadratic formula. And then that would give us the 3 zeros that we're looking for. Okay, so again, we'll do some examples right now. So here it says find the zeros of the polynomial function. And they give us our polynomial. And then it says what is the difference between this example here and the previous one. So let me go to the previous one. So find the zeros of the polynomial function given that x equals 4 is a 0. So look at this instruction here, and what is the difference between this instruction here? What is it missing? Okay, what's missing is, let me go back to the previous one. In this instruction here, they tell me that x equals 4 is a 0, and so automatically I was able to use synthetic division with my 4. But if we look at this instructions over here, they don't give me 1 0, right? They don't say anything about a 0. So how can we proceed with synthetic division if we don't know 1 0? Okay, so in 2.5, we use the possible rational zero theorem test. And what that does is that it's going to, since we have an infinite amount of numbers, we don't want to try those because we would never finish. But what this theorem does is it breaks it down into a shorter list. And in order to use this theorem, we're going to use the factors of the constant term, which is your last number without the variable, and the factors of the leading coefficient, which is the number in front of the variable with the highest exponent. And just as a refresher, what is a factor? It's all the numbers you can multiply together to get that number. So 1 times 8 is 8, 2 times 4 is 8. Okay, so 24, these are the factors. So the first step in finding the zeros for this polynomial is going to be to get a list going. And so we'll get the factors of 9. And the factors of 9 are 1 times 9 is 9, and 3 times 3 is 9. You don't have to worry about the negative here because we are going to go ahead and use the plus or minus for each of these numbers. And then the leading coefficient here is 1. So the factors of 1 is just 1. So we're going to write that as the quotient. So I'm going to have my plus or minus 1, plus or minus 3, plus or minus 9, and plus or minus 1. The reason we use the plus and minus is because we can combine these numbers so that we can get a negative 9. So I could use a positive 1 and a negative 9, and it would still give me the negative 9. Or I could use a negative 1 and a positive 9 to give me a negative 9. So we want to include all the possibilities here. Now we divide, so 1 divided by 1 is 1. 3 divided by 1 is 3. And 9 divided by 1 is 9. Okay, so these are the possible rational zeros. And so if you notice here, we have 2, 4, 6 zeros. Instead of checking infinite amount of numbers, we can start with this smaller list. What I always like to do for myself, and I encourage people to do it, is start with 1. And so we take the 1. So this is step number 2. We're going to take the 1 and we're going to apply synthetic division here. So I list my coefficients. Don't forget, if you're missing a term, you want to use a 0. we bring down the 1. 1 times 1 is 1. 1 plus 1 is 2. Then we're going to multiply 1 times 2, and that's going to give me a 2. Negative 9 plus 2 is negative 7. And 1 times negative 7 is negative 7, plus 9 gives me a positive 2. So if you notice, the last number here is not a 0. And so unfortunately, we are going to not like that, right? We cannot say that x equals 1 is a 0 because our remainder is not 0. Okay. So what that means is, okay, 1 didn't work, so we try another one. So I'm going to try negative 1. So we bring the 1 down. Negative 1 times 1. Negative 1 plus 1 is 0. Times negative 1 gives me 0. Plus negative 9 is negative 9. Times a negative 1 is going to give me positive 9. And let me make sure that I wrote this right here. So this 9 here is missing a negative. And so let me just write it here. I forgot my negative here. So this should have been a negative because I have my negative here. So negative 9 plus 9 is going to give us 0. Okay, so once we get remainder of 0, then that makes us happy because x equals negative 1 is going to be a 0. So once we do that, then the other reason it's going to make us happy is because we can use the quotient. Okay? So let's look at our step 3 is use the quotient. Since we had a polynomial of degree 3, when we write our quotient, we're going to start with degree 2. So we have the 1 for x squared, we have a 0 for x, and then we have a negative 9 for our constant. Okay. Notice that this is quadratic, so now we have options. We can use a square root property, we can try to factor it, or we can use a quadratic formula. Okay, so let's go ahead and add 9 on both sides. So we get x squared equals 9. We can take the square root on both sides. So the square root and the x squared become a 1. So we get x is equal to plus or minus 3. Okay, so our zeros are going to be the negative 1 that we had here, the positive 3, and the negative 3. Okay, so these are going to be all of our zeros. Any questions on this example? Okay. Now later on in this section, you're going to be asked to use the factors. So if the question says, write your polynomial in linear factor form, then all you have to do is take your 0, and we're going to add the 1, so we get x plus 1. And then the negative 3, we can add it to the both sides, so we get x plus 3, and x equals 3 would be x minus 3. So these factors, if you multiply them out, will give you this polynomial. Okay. So let's try another example here. So we're going to first use the rational 0. And so we're going to have the factors of negative 1, which is plus or minus 1. The factors of 2 is 1 and 2. And then we're going to divide them. Okay, so we're going to divide 1 divided by 1 is 1. And 1 divided by 2 is a half. Okay, so these are possible zeros. Then you can pick anything. If you wanted to start with the half, you could start with the half. I'm going to go ahead and start with the 1. So if I want to apply synthetic division, then we're going to have 2, 3, and notice that there's no x, so I'm going to use a 0, and then I'm going to have negative 1. Okay, so we bring down the 2. 1 times 2 is 2. 3 plus 2 is 5. 1 times 5 is 5. 5 plus 0 is 5. 5 times 1 is 5, and negative 1 plus 5 is 4. So x equals 1 is not a 0. Okay, so we try another one, maybe negative 1. We're going to bring down the 2. Negative 1 times 2 is negative 2, plus 3 is positive 1, times negative 1 gives me a negative 1 plus 0 is negative 1 times negative 1 becomes positive 1. So we get the 0 that we want. So that would make us happy again. And so more importantly, that tells me that negative 1 is a 0. Okay, so my next step is to use these numbers here to write the quotient. And so my quotient, I have the 2. So I write down the 2. Since I had x cubed, I'm going to start with x squared. Then I have the 1 for x, and the negative 1 is my constant. And notice that it's quadratic, so we have options. We can factor or use a quadratic formula. Now factoring doesn't always work, and so in this case it does work. We get 2x minus 1 times x plus 1. Give me a second really quick. Give her a lollipop or something. Okay, so we set each factor equal to 0. So we get 2x minus 1 equals 0, and x plus 1 equals 0. So we're going to solve for x. So we add the 1. We get 2x equals 1. Divide by 2. So we get x equals a half. And on the next one, we subtract the 1. So we get x equals negative 1. So we should have 3 zeros. So we have 1 0 here, a half here, and our third 0 was negative 1. Okay, so we had the negative 1 from here, we had the half, and then we have another negative 1. So the multiplicity of this negative 1 is 2. So when you graph it, the graph is going to touch it and turn. Okay, any questions on that one? So it would be nice if they were all cubed like this, right? But sometimes they're not, and so you have to repeat the process. And I think I have an example of that. Okay, so let's see. So here we have another one, right? So the factors of 4 are 1, 2, and 4. The factors of 1 is 1. So my possible zeros are 1 divided by 1, 2 divided by 1, and 4 divided by 1. And we're going to check synthetic division. So I'm going to speed up the process a little bit. So you've noticed if we use 1, it didn't work. If we use negative 1, it doesn't work either. Okay. If we use 2, we got a negative 4. If we use negative 2, we got negative 20. So what's going on? If we use 4, we get this 4 here. Negative 4 gives me 132. So none of the zeros that were in my possible zero list gave me a 0. Okay, and that's okay. What that means is that there's no rational zeros for the polynomial. So perhaps this polynomial might have complex zeros or irrational zeros. And just so that you can see what it does have, it has 3 irrational zeros. Okay, so they're right here. And in order to find these irrational zeros, then that would take a whole different lesson. But for 1314, it does not cover the method for finding these zeros here. Okay. So in your next class, that's where you'll start to learn different methods to finding those irrational zeros. So let's try one that's a little bit different. This one is the power or the degree is a 4th degree polynomial. And so it's a pretty long polynomial. But the process is still the same, right? So my constant is 24. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. The factors of 9 are 1, 3, and 9. If we divide them, so we have this long list. And so here we would go 1 divided by 1 is 1. And then 2 divided by 1 is 2. 3 divided by 1 is 3. And then 4, 6, 8, and 12, and 24. And then we start with the 2. 2 divided by 3 is 2/3. 1 divided by 3 is 1/3. 3 divided by 3 is 1, but we already have it, so you don't have to write it again. 4 divided by 3 is 4/3. And 6 divided by 3 is 2. and 6 divided by 9 is a third. Then we go to the next one, right? So we keep going until we finish with a 9. So 1 divided by 9 is 1/9. 2 divided by 9 is 2/9, and so on. So in your homework for 2.5, you have to enter the list, and so you want to make sure to enter the plus or minus 1. It might not have the symbol for plus and minus, so you might have to enter it as 1 and then -1. Okay. So these are all your possible zeros. So we're gonna pick 1. I like to start with 1. So if we do the synthetic division, it doesn't give me 0. Okay. So we'll try -2. We bring down the 9. 9 times 2 is -18. Plus -9 gives me -27 times a -2 gives me a 54 plus a -58 gives me a -4 times a -2. That would give me a positive 8 times 4, or 8 plus 4 is 12 times a -2 gives me -24, which is our 0. So that tells me that x equals -2 is a 0. Okay, so my quotient, since I had degree of 4, I'm going to have to start with degree 3. So I'm going to give you, like, 10 seconds. You can write it on your own paper, or you can say it in your mind what you think the quotient is, and then when I click on it, you'll see if you got the right answer. Okay. Okay, so hopefully this is what you thought about. 9x cubed minus 27x squared minus 4x plus 12. So again, you start with 1 degree less. So here we're going to end up with x cubed because we started with an x to the 4. So now, but this is different, right? Because when we do synthetic division, our next step is to get the quotient, and it normally was a square or quadratic. And then we can either factor or use a quadratic formula. But this time, it didn't do that. It gave us a cubic. And so what can we do to solve this? Okay, there might be two options here. If you look at this polynomial, you have 4 terms. Okay, and so one possibility is to factor, set it equal to 0, and then factor by grouping. And so if you feel comfortable with factoring by grouping, then you can check to see if it's factorable. But if you're not sure, or you're not comfortable with grouping, then it's okay. What we would do is we would start the same process. So now we would look at this polynomial, and we would do the p over q to get the possible zeros. And so I'm going to just list them here. They're the same. Okay. And then we would start with synthetic division. So here's my 9, my -27, my -4, and my 12. So bring down the 9. 9 times 3 is 27, plus -27 is 0. Multiply the 0 times 3. I get 0, plus -4 is -4, times 3 is -12, so I get a 0. So that's great news, right? We ended up with a 0. So you might have tried 1, you might have tried -1, and it didn't work. Maybe you tried a 2, but the 3 is the one that worked. Okay. So yes, sometimes you have to try a couple of numbers before you can find that 0. Another thing you can do is maybe use a graphing device if you're able to use it, and see where the 0 is. And if you have to show your work, you can still show your work. Okay, but sometimes depending in your with your instructor, you might not be able to use those graphing devices, and so this would be the best way to go about it. So now let's look at the quotient. Okay, so since we have x cubed, this 9 is going to begin with an x squared. So 9x squared minus 4. So now notice it's quadratic, so we can set it equal to 0. And I'm going to use the square root property, so I'm going to add 4 on both sides. And then I'm going to divide by 9. So I get x squared equals 4/9. Take the square root on both sides. Okay. The square root of 4 is 2. The square root of 9 is 3. So I get x equals plus or minus 2/3. Okay. since we wanted to find all the zeros, let's try to put all this back together. So one of the zeros was -2. The other one was x equals 3. And then the last one was 2/3 and -2/3. So we have 1, 2, 3, 4, and our degree is 4. So that means we have found all of our zeros. Okay, any questions on that one? Okay, let me go to the next slide. So the beginning of 2.5, just here the factors again. The reason I put the factors here is because you will be asked to do something with them in this section. So to get the factors, remember you just take everything to the left side. So I add 2 here and I get x plus 2 and so on. Okay, so the last thing, the last type of questions you're gonna have is where they ask you everything together. So they want you to list your possible zeros, list all the real zeros, and then they want you to sketch the graph. And I believe we already did this this same example, so for the possible zeros, and so we're just gonna list them there. Okay, so it's plus or minus 1, plus or minus 3, plus or minus 9, and then we also found the zeros. So this was a previous example. We used synthetic division, got our 0, and then we used the square root property. So these were our zeros. Okay, so those are your first steps: is find the possible zeros, then find your actual zeros, and then to sketch the graph, you want to consider the following. Okay, to sketch the graph, you're going to consider, you're going to need to know the end behavior of the graph, the multiplicity of the zero, and if it touches or crosses. And then you're going to need to know the zeros, which are letter B here, and then the y-intercept. Okay, so we're going to do these here. A review, just for those of you that, this was from section 2.2, I believe. So if you have an even power with a positive leading coefficient, then we say that the graph rises to the left and rises to the right. If you have a negative leading coefficient with an even power, then the graph falls left, falls right. And then the x cube, if it's positive leading coefficient with a odd degree, then it's going to rise right and fall left. And then negative x cube, which means odd degree, negative coefficient, you're going to rise left, fall right. Okay. So our example, which behavior will our function have? Will it be A? I'll say A here. B for this one, C for this one, or D? What do you guys think? A, B, C, or D? You can throw it in the chat if you like. So is it gonna look like this, or like this? So it is gonna be C, right? Because we have a cube, and this is positive, so that's gonna look like C. Okay, so the graph will rise and it's gonna fall left. So we're gonna use that information in a little bit. Okay. Now the multiplicity of our zeros are, this is just a review here too. Okay, this is not part of the actual problem. This is only to tell you if the zero appears an even number of times, then it's going to touch and turn. If it appears an odd number of times, then it's going to cross. Okay, so let's go back to our problem. So the end behavior is rises right, falls left. The multiplicity of our zeros are -3. Since it only appears one time, then we'll say it's going to cross. -1, since it only appears one time, it's going to cross. And x equals 3 appears one time, so it's going to cross. The y-intercept is found by letting x equal 0. So we're going to put our 0 here. Anywhere you see an x, you put in a 0. So my y-intercept is 0, -9. And then your last step is going to be to pick additional points. Okay. So this last step, I would encourage you to wait until you have already plotted everything else. Okay. And so we're going to plot our zeros. And so the pictures for this one didn't come out um, because I saved it with the pen. So let me just go to the next slide because you're not going to be able to see them there. So let me go to the actual graph here. Okay, so you would plot your zeros here. So there, this is going to be one of the zeros, -3, and then we had our other zero here, which is -1, and then we had our +3. So you would plot that first. Let me use the pen here. So you want to plot this first, and these are closed circles, okay? Um, I actually left my whole backpack in a car that I was riding in, and I'm using another laptop that doesn't have a pen, so just bear with me here. So that would be the first step, is plot these red points. Then your y-intercept was -9, so that's going to be down here. It's out of the picture, but you can leave it there if you're drawing it on paper. But for the end behavior at this point here, we know that the graph is going to rise right. So that's why it extends up. So I would, with a pencil, I'm going to pretend like I'm drawing it here, and I'll use blue. So normally I would just draw a line up, okay? And I know it's going to cross, so I would draw my line down, and that's all I would draw. And then on the left side, I know it's going to fall, so I would go down, and I know it crosses at this point, so I would go up, okay? At that point, all I have is the blue line, the two blue lines, and the red points, okay? So now that's where plotting additional points would be important, and you want to get points that are between your zeros here, because you want to know what happens here, and you want to know what happens in here, and if you need to, you can get some on the outside. So that's going to be up to you to determine how many zeros, but for sure you want to have zeros between, you want to pick points between the zeros, okay? So let me go back so we can see where I picked those points. And so here I picked -2, and when we do -2 and we plug it in for all our x's, we get 5, okay? And then we also picked 1, so when you plug in the 1, we get -16, and then we did 2, so when you plug in the 2, you're going to get a -15. And so for -2, we get a 5, so let's look at that in the graph. So -2, we get the 5, which is up here. And then for 1, we get -16. So 1 is right here. -16, I have it outside. It's not in the picture right now. And then 2 was -16. So then that helps me to connect my graph. So now I know that the graph is going to go up. And then it has to come back to this 0. And I know it's crossing, so it's going to come down to your y-intercept. And then it's going to turn back up, okay? And so those are the steps that you would take in order to graph your polynomial. Okay, so any questions on that last graph? Okay. So find another question that you'll be asked in 2.5 is to find a polynomial with real coefficients that have the given zeros. So we have 3 minus 4i, okay? So they tell you that these are zeros, right? So what we're gonna do and what our goal is to find a polynomial that looks something like this. Okay, and all we have is that x equals 3 and x equals -4i. So you're kind of going to work backwards. You are given the zeros, and so you're going to work backwards to find the factors and then get the quotient, and then that's going to give us our polynomial. Okay. So since I have two zeros here, we have 3 and -4i. -4i is an imaginary number, complex number, and we know that they come in pairs. So x equals -4i, that means that the conjugate is going to also be a 0. So x equals 4i is the conjugate of -4i, and that's going to be a 0. So now I have 3 zeros. So I know that my degree is going to be 3. So we're going to list the factors. And so remember the factors, we just have to take the positive 3 to the left side, and I can do that by subtracting, so I get x minus 3. I'm gonna add 4i on both sides, so I get x plus 4i, and I'm gonna subtract 4i, so I get x minus 4i. Since they're factors, I'm going to set it up a polynomial like this. So I have x minus 3 is my first factor, and then my 2 other factors. But notice that in the front, I put an because I don't know what my leading coefficient is. So I'm just going to put a placeholder here of an. Okay. So we need to multiply these out. I personally like to multiply the complex numbers first. And so I'm going to go x times x is x squared. X times negative 4i is negative 4ix. 4i times x is 4ix. And 4i times negative 4i is negative 16i squared. If you're multiplying correct, and these are your conjugates, then these two middle terms will always be a 0. Okay. So if you don't get 0 here, that means that maybe you put the wrong conjugate or you multiplied incorrectly. So let's reduce this. Negative 4ix and 4ix becomes 0, and I'm left with this. However, I know that I squared is equal to negative 1. So negative 1 times negative 16 is positive 16. So I get x squared plus 16. Now I'm going to multiply it to x minus 3. So x times x squared gives me an x cubed. X times 16 gives me a 16x. Negative 3 times x squared is negative 3x squared. Negative 3 times 16 is negative 48. You want to combine your like terms if you have any. We don't have any, but I personally, I like to write them in descending order. So I just switch my negative 3x squared with the 16x. And so this is going to be our polynomial. In some examples, they're going to give you more information. Here, this is all the information they give me. So my leading coefficient could be really anything. But since you don't have any more information, we can leave it as a 1. Okay? So I'm going to just leave it as a 1. And this is the answer that I would input into my computer. Okay? However, this 1 can be different based on information that they're going to give us. And I think I have an example, but we'll check right now. Yes, we have an example. So this one tells you that we have degree 4, negative 4, 1, and I are my zeros. But now they give me this new information, f of 0 is equal to negative 8. So this information here is going to help us determine what our leading coefficient is. Since I have degree 4, that means that I'm missing a 0. What 0 am I missing? Which one do you think I'm missing here? Would it be a positive 4, a negative 1, or a negative I? Okay, so remember that your imaginary numbers have to come in pairs, so that means that we're missing a negative I. Okay, so your fourth 0 is negative I. So first we get the factors. We get x plus 4, x minus 1, x minus I, and x plus I. So we're going to write it out as a linear product of factors. And so again, in your assignments, you might have that question. Write your zeros as a linear product of factors. All they're asking for is these factors right here. So multiply the imaginary numbers, x times x, x squared, negative ix, and positive ix, and then I times negative I is negative I squared. So notice your two middle terms will become 0. And then we're going to replace this I squared with a negative 1. So we get x squared minus a negative 1, which is going to become a positive 1. So now we're going to multiply the next two parentheses. X times x squared is x cubed. X times 1 is x. negative 1 times x squared is negative x squared. Negative 1 times 1 is negative 1. And last, we multiply the last parentheses. X times x cubed is x to the fourth. X times x is x squared. X times negative x squared is negative x cubed. And x times negative 1 is negative x. 4 times x cubed is 4x cubed. 4 times x is 4x. 4 times negative x squared is negative 4x squared. And then we get negative 4. We want to clean it up a little bit, combine your like terms, write it in descending order. So we get x to the fourth, and then we have an x cubed here and a 4x cubed. So that gives me 3x cubed. I have an x squared minus 4x squared gives me a negative 3x squared. And I have a negative x and a positive 4x. So that gives me a positive 3x, and then my minus 4. Okay. So in the example before, we were able to stop here, but now we have to use this other information here. So f of 0 is equal to negative 8. So what this means is that your 0, it's telling us if x is 0 and you plug it in for all your x's, then your answer is negative 8. Okay. So what we can do with that information is f of x is going to be negative 8. And then anywhere that you see an x right here, these x's, we're going to replace them with 0. Okay, so if I do that, then this is 0, that's 0, that's 0, and that's 0. So we're left with negative 4. We're going to divide by negative 4. So we get 2. Okay, so that's going to tell us that this number out here is a 2. So the last step is multiply it into the parentheses. So we get 2 times x4 is 2 to the x4, 2 times 3 is 6x cubed, and so on. And so now this is going to be your final answer with us finding that leading coefficient, which was 2. Okay. So if they give you the solution point, you do have to have a leading coefficient other than 1. Sometimes it might still be a 1, but you know, it could be a different number. Like in this case, we got a 2. Okay, so this is I guess some examples of what you're gonna see in 2.5. In my other PowerPoint that I was gonna share with you today, I had included some examples of 2.6, but like I mentioned, I left my whole backpack. I don't know how I did that in the other car, so I it's in Fabens right now. Anyways, so we do have about, I don't know, 16 minutes. So I can answer any specific questions you might have. Um, I could answer some questions from 2.6 if you like. For next week, what we'll do is we'll spend part of our time. We're gonna do an exam 2 review, but we'll in that review, what we'll do is we'll start with 2.6 questions, and then like examples, 2.6 examples, and then we'll work our way down. Okay. So if you have any specific questions, please just let us know. Even if let's say you have a question in WebAssign, you can just let us know. We can look it up and work it out. But thank you for joining us. It's always something that I look forward to every Friday is a Friday Happy Math Hour. And so thank you for joining us. And we're going to stick around. So if you have any questions, please stay here and ask us.
Thank you, Ms. Chuka. So the link is posted. Actually, I don't think it's posted yet in chat. Helen, do you have it? I posted it on the whiteboard, so if you guys can see it, for those watching the videos, that would be our link for today. Thank you, Emma. I'll be stopping the recording now.